The year is 2099. Humans have been traveling in space for 150 years. Every part of our solar system has been explored. Missions to the nearest stars are on their way. But space travel has proved hazardous for human beings. And death lurks in the hostile environments of the planets and their moons. And so, through human ingenuity, a new breed of space explorer has been perfected. These are the SIMs, 5 super intelligent machines capable of operating in the most extreme and threatening conditions. Earthlink, the mighty spaceship which carries them across the void. On board is Lander, the transfer vehicle and sanctuary while on a mission. Inside are Legs, who tackles the most dangerous terrain. Wheels, the roving scientific detective. And Hover, the rescuer and scout. This team of trailblazers acts as agents for the human race, adventuring far into the solar system and beyond. Their destination, space. Out beyond the 4 giants of the solar system, Jupiter, Saturn, Uranus, and Neptune, there lies one more planet, Pluto, with its moon Charon, twin targets of the SIM's mission in 2088. Pluto is the smallest of the planets, its diameter less than the distance across North America. 3 of Jupiter's moons are larger, and Charon is half Pluto's size. The SIMs would go to Charon first, and then to Pluto. Their main goal, to discover the pair's origin.
This is one of the furthest missions we've ever undertaken, right to the edge of the solar system.
Out there at Pluto, the sun only looks like a bright star.
Which means we can't use solar power. We have to take all our energy supplies with us.
Control tower, mission to Pluto requests clearance for takeoff.
This round trip is almost 8 billion miles.
Final countdown. Launch team checking our status. All systems nominal. Powering up and rolling. V1, V2, rotate.
That's the first 250 miles on the clock. Just 4 billion miles to go.
At that distance, we have to solve any problems ourselves. It takes 5 hours for radio messages to reach Earth.
Pluto and Charon are 15,000 times further away from Earth than the Moon. On these remote worlds, the sun's rays are 1,000 times weaker than on Earth. Pluto's path around the sun, on the fringes of the solar system, is more elliptical than the orbit of any other planet. When at its closest to the sun, Pluto develops a flimsy atmosphere of nitrogen. When its distance from the sun increases, the atmosphere freezes onto the planet. The SIM's mission was planned to take place while Pluto had its atmosphere. To reduce the travel time, Earthlink will be powered by a newly developed antimatter propulsion engine, the mighty APE.
Prepare for space station docking. The ion drives are to be put into storage here. We'll use our main rocket to cruise as far as Mars. The antimatter propulsion engine to whisk us to Pluto will be fitted at the Phobos base.
What equipment is being loaded here this time?
My navigation computer needs extra shielding from radiation. For communications with Earth, we'll be taking a carbon composite transmitter.
But messages to and from Earth will still take 5 hours.
Of course. They can't go faster than light.
We'll be leaving a cryo-crawler on Pluto as a robotic science station. He now has a plutonium battery that's good for 5 years.
I'm downloading instructions on a seismograph network.
It's for probing deep inside Pluto. Engineering and loading complete. Stand by for undocking. Our next call is at Phobos.
Where we get our real driving engine for the mission to Pluto.
Years ago, we set up the gateway station called Phobos Space 1.
Yes, here's that mission from the memory bank. It was groundbreaking work, but look at Phobos Space 1 today. There's an antimatter factory, the only one in the solar system.
Why is the antimatter factory out at Phobos?
For safety, when matter and antimatter merge, they create pure energy. Antimatter is the most dangerously explosive stuff there is. A millionth of an ounce would vaporize a human.
Launching now for Phobos Space 1 to collect the APE. Earthlink, this is Lander. I have the APE on board.
Come in, Lander. I read you at 1 mile and closing.
Matching orbits now.
I have you alongside for the transfer.
Releasing APE now.
This isn't going right. The APE is drifting.
Watch out. It's going to hit you.
Only a glancing touch. I'll track its drift. The orbit it's on now looks dangerous. It's going to crash on Phobos unless we can stop it in the next few minutes.
Hover, stand by for EVA to retrieve the APE. I copy you. Launching now. Legs, we need your help too. I can't do it alone.
I'm on my way. I've got a fix. Hover, are you secure?
Affirmative. Let's start moving it to the correct position for alignment. Earthlink, maintain track.
We've done the simulation many times.
But the real thing's harder. I can't get it to engage.
Just take it steady, like we practiced.
It's not going to work.
That's it. You did it. All couplings secure. Come on board now.
And let our mighty journey begin.
Emission exhaust aligned to clear the Mars-Phobos system. Proton-antiproton factory on. Storage rings on. Collider chamber on. Now for the final test. Go for antimatter drive. We have ignition. Exhaust velocity 9/10 speed of light.
What acceleration! We're already at 10 G.
The antimatter drive is over 100 times more efficient than nuclear power.
Our speed is going up amazingly fast.
Hold on 10G until we reach 5 million miles per hour. That will take 2.5 days. Then we cruise for 30 days to Pluto. We've reached maximum speed, 5 million miles an hour.
Antimatter drive off.
That went smoothly. Now for a review of what is known about Pluto.
Early in 1930, a young astronomer called Clyde Tombaugh was searching for a ninth planet and found a faint object moving slowly against the distant stars. He had discovered Pluto on its 246-year orbit around the Sun. In the next half-century, astronomers learned that Pluto is a world of ice, where the surface temperature is 430 degrees below freezing. A big surprise came in the 1980s. Photographs of Pluto showed a slight bulge, first on one side of the planet, then on the other. The bump turned out to be a moon orbiting Pluto. It was named Charon. Charon and Pluto are uniquely close in our solar system, separated by only a little over 10,000 miles. Both are a mixture of rock and ice. The first images to show any real features came from the Hubble Space Telescope in the 1990s. These images, when made into a map, showed vague bright and dark features. If Earth's moon was imaged at this low level of detail, it too would only show vague light and dark patches. Pluto rotates in 6.5 days, the same time it takes Charon to complete an orbit.
We're 95% of the way there. Stand by for deceleration.
I copy you. Rotating 180 degrees. Commencing retroburn. Passing Pluto now, on course for Charon orbit.
Lander, stand by to launch for exploration of Charon.
I copy you. Launching now. This is like Triton, the ice moon of Neptune. There are chasms and ice cliffs. And one of those venting geysers, similar to the ones we saw there.
That means Charon may be active, with an interior kept heated by the tidal pull of Pluto.
No worse conditions than on Triton. Let's go for a landing. This is a short stopover. Concentrate on surface samples to help uncover Charon's origin.
I'm going to investigate the surface dust first. Isotope analysis will give its age.
It's astonishingly cold here, despite those puffs of gas from the geyser over there.
I'll check out the neighborhood.
These samples from the surface are amazing. I'm getting age readouts of billions of years.
Billions? But it's almost like fresh snow underneath. That old dust must have got here from the comet swarm way out beyond Pluto.
There are small surface rocks over here.
They look fresh, And there are rocks inside the ice that I can get out for you, Wheels.
These are silicates. They aren't from space. They are rocks from the interior, probably thrown up by motion in the ice.
Now hear this. I've made a great discovery. Charon has a thin atmosphere.
Surely the gravity here is much too weak to hold onto an atmosphere. What's the composition?
There's methane from that geyser. The rest of the atoms match Pluto's gases.
Pluto's gravity is so weak, its atmosphere drifts off into space. Charon must be scooping it up.
The Charon phase of our mission has gone well.
What do you reckon the scientists on Earth will make of our discoveries at Pluto's moon?
They should be thrilled, Legs. We've shown that Charon has a rocky interior, so it's more than just a great heap of cometary ice. And Hover's discovery of an atmosphere was a complete surprise.
Welcome back. You had great success at Charon. And now for the first ever landing on the 9th planet.
But not the very first mission to Pluto.
No. Back at the beginning of the 21st century, there were a number of flybys. Have a look at the archive.
Pluto's immense distance required a lightweight spacecraft that could be sent at high speed. In 2015, the first small craft to reach Pluto and Charon swept by, grabbing images during just 1 hour. A second, identical craft followed 1 month later. Their data remained the best available on Pluto prior to the arrival of the SIMs in 2088.
Pluto, the last planetary outpost. Lander, stand by for launch.
I copy you. This mission puts us in the record books again. Radar indicates a fairly flat surface, nothing higher than 1,500 feet. There are deep gullies and fissures in the rock and ice surfaces. We're landing near a border between a snowfield and bare rock. Welcome to the 9th planet. There are 6 moons in the solar system that are bigger than this world.
We've got to find out if it's a real planet by probing its insides. If it has a dense, rocky core, it's a planet.
Let's get going with the science experiments. Bring out the cryocrawler, Hover.
I copy you. Launching now. Good. The cryocrawler is off on his random walk exploration.
How long can you keep that up?
5 years on plutonium energy. He'll be sending data long after we get back to Earth.
Now we must set up the seismograph network. This is the center point.
I've got 4 to deploy and set up at distant locations.
When they're in place, I'll set off some explosions. The seismographs pick up the vibrations, which tell us what Pluto is like inside.
We'll make Pluto quake.
That's the first in position. I've brought this last seismograph 100 miles to complete the network. Set off the explosions, Legs.
These powerful charges should give us the answers.
Stand by. Lander has the computer to read Pluto's structure from these explosions.
The quake vibrations are echoing off a dense core. We're on to an important discovery. Pluto has a core of solid rock.
That means it is a real planet, not a dead comet.
I'm doing the ice samples now, and reading solid nitrogen plus methane and water.
We need plenty of rock fragments. I'll start cutting them with the mega lasers.
These are silicates, just what we expect for a real planet. What has Hover found?
There's a valley in the ice over here. Let's all explore it and see if any old layers are exposed deeper down.
These valley walls are steep. It's not going to be easy to check them.
You should tether yourself before starting. Hover is right. Older ice is exposed around here.
I'm starting down.
Take care.
Easy does it. Ah! I've lost my footing.
Hold on, Legs, while I assess the problem. I'm checking the tether.
Pull me up with it. Come on. We need to get on with the experiments. I'm not moving. Pull harder.
I am pulling. It must be jammed somewhere.
I can see the problem. It's snagged between some rocks. I can't reach it. Lander, we need help.
Yes, this is useless.
I'm assessing the options. The best solution seems to be the cryocrawler. I'm beaming instructions for him to move to your location. Downloading your coordinates now. You'll have to sit tight until he arrives. His design functions don't allow for sudden changes of programming in mid-operation. Sounds as if we're in for a long wait. The cryocrawler's so slow.
We should enter sleep mode, otherwise our batteries will be flat by the time he gets here.
I agree.
Closing down now, Legs.
Lander, wake me up when the line is free.
Slowly but surely, the cryocrawler drew closer to the stranded SIMs. After a 10-hour wait, rescue was finally at hand.
Power up, everyone. Cryocrawler's done it. Now you can haul Legs back up.
My batteries seem fine, but I'll take it gently.
I'm all systems go as well. Moving into position to monitor progress. Wake up, Legs! Action at last! Wheels is getting ready to pull you up.
Hey, not too fast. You might damage my rear-mounted systems.
Nearly there now.
Thanks, Wheels. It'll be good to be back on my feet. My battery is almost dead.
Go on, Legs. Squeeze out the last bit of power to get on board. Then you can charge up again.
Just made it. Securing now.
Something odd is happening in the atmosphere. What's this stuff coming down?
Nitrogen snow. The atmosphere is freezing out on us. Let's go before we get frozen to the ground. All hatches secure. Stand by for takeoff.
Welcome back, Lander. You are clear for docking.
Only another 4 billion miles back to Earth.
The SIM set out on the return journey to Earth carrying precious samples of rock and ice that would help unravel the earliest history of the solar system. They had made the unexpected discovery of Charon's atmosphere and had shown that Pluto and Charon are true planets, a unique pair on the far fringe of the solar system.